bond, the bond formed by the mutual contribution. It's not from one element. From both, whichever element which is taking part in the chemical reaction, bond formation, both the elements will be contributing the electron. So there will be mutual contribution and sharing of electron in participating atoms. Okay, and covalent bond is seen generally in non-metals. So we don't see covalent bond formation in metals. It is always in non-metals, between non-metals. Okay, and here energy requirement for forming a covalent bond is very less, okay, very little, because of which they form the covalent bond. Bond may be formed between same element or different element. That means if at all a hydrogen molecule, how hydrogen molecule is formed? It is sharing of electron between the same atom, between the same elements. So that is, it may be between the same element or between different elements, as in case of hydrochloric acid, HCl, different elements. So if the bond may be formed between same element or different element. Now let us see how covalent bond is formed. So let us see few examples for covalent bond formation, and this is very important. Okay, covalent bond formation or the dot formula what we'll be writing now is very important for examination point of view. So let us start with the simple one, that is formation of hydrogen molecule. So we know hydrogen molecule H2, O2, Cl2. So these are molecules. So let us see how they are formed. Formation of hydrogen molecule. Hydrogen molecule. Hydrogen molecule. So hydrogen molecule was the formula, you know, it is H2. It is H2. So let us see what is the atomic number of hydrogen. It is 1. So it is not stable. If it gets 1 electron, it will become stable. It will get the helium configuration. So what it will do? It will combine with another, it will combine with hydrogen, another hydrogen atom. Okay, that is hydrogen. Okay, will combine with one more atom of hydrogen. So how do you represent this? Okay, so you can use different structure. Always start with one dot, or just for other one you can use different structure like this. So we have two hydrogen atom, and two hydrogen atom also need one electron. Each need one electron to become stable. So this is how it is. Okay, so let us just put this dot for the structure. Okay, now both will share the electron. When they share the electron, so I will represent one electron like this, the other electron like this. This electron is for this hydrogen, and this electron, this one is of this hydrogen. So they will share the electron. They will share the electron. Okay. Now you see this hydrogen has got 2 electrons, so it becomes stable. And this hydrogen also got the 2 electrons. It's a pool. Okay. In the pool they got they are sharing the electron. How many electrons is sharing? It is sharing 1 electron. Each sharing 1 electron. So as they are sharing 1 electron, we put this dash here. The dash indicates, this dash indicates how many electrons they are sharing. So when you have only 1 dash, they are sharing 1 electron each. They are sharing 1 electron each. So they form single covalent bond. So this is single covalent bond. Okay, Understood? So this is dot formula which you have to learn. Okay, so let us do one for the next molecule. Let us take chlorine. Let us take chlorine. So chlorine, you know, it is Cl. Okay, chlorine molecule is Cl2. So what is the valence electron for chlorine? You know the atomic, electronic configuration. You know the valence electron is 7. So let us distribute the electron. Okay. Right. So 7 electrons are there. So it is combined with another chlorine atom. Whenever you are showing this electron, just make sure where they are going to share that particular electron, they only leave it vacant. See? So it needs 1 electron here, it needs 1 electron here. Okay? So like that you arrange the dot. Okay? So they combine. Okay? So now this 1 electron is here. So let me just and this 1 electron of this chlorine. So you have to show that they are sharing by putting like this circle. Right? How many electrons they are sharing? Each they are sharing 1 electron. So Cl dash Cl. So Cl2, here it is single covalent bond. Yes, understood Cl2? Okay, let us do for oxygen. Let us do for oxygen, that is O2. Oxygen molecule. Oxygen molecule. For oxygen molecule, that is O2. You know atomic number of oxygen? It is 8. Electronic configuration 2, 6. How many electrons it needs? It needs 2 electrons to become stable. So let us represent the electrons. Okay. So 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. See, these they will be sharing, so that's why I am putting here. Can you see now? How many electrons each are sharing? They are sharing 2 electrons. Each are sharing 2 electrons. See 1, 2, 3, 4, 5, 6, 7, 8. So this has got stable configuration. So let us see this oxygen. 1, 2, 3, 4, 5, 6, 7, 8. So it got 8 electrons and it has become stable. So this is how they shared and they obtained the stable configuration. Now let us see how many electrons they have shared. They have shared 2, right? So they have shared 2 electrons and we have to put 2 dash. So when you put 2 dash, so it represents that has shared 2 electrons. Each has shared 2 electrons. These 2 electrons they have shared. So what has formed? They have formed double covalent bond. It has formed double covalent bond. Yes, understood now for O2 alkane. Next, let us see for nitrogen. distribute the electrons. So 2 and 5. How many electrons it needs? It needs 3 electrons to become stable. That means they have to share 3 electrons, right? Nitrogen molecule N2. So N plus N. So how many electrons they have to share? They have to share 3 electrons. Okay? So 3 plus 2, 5. Now we check. See, 1, 2, 3, 4, 5, 6, 7, 8. So it has become stable. This nitrogen 1, 2, 3, 4, 5, 6, 7, 8. So how many electrons they have shared? They have shared 3. They have shared 3 electrons. So it has formed triple covalent bond. All these are important. Single covalent bond, double covalent bond and triple covalent bond. So this what we have seen so far is the covalent bond formed between homoatomic molecule. These are homoatomic molecule. Homoatomic molecule means between the same atom like hydrogen and hydrogen, oxygen and oxygen, N and N and chlorine and chlorine. Same atom. Okay? Homoatomic molecule. Now let us see for heteroatomic molecule. Heteroatomic molecule. Heteroatomic means what? Between two different elements. Heteroatomic molecule. So let us take a simple example. Okay? HCl. Okay? Formation of covalent bond in hydrochloric acid. So let us put hydrogen plus chlorine. Hydrogen wants only 1 electron to become stable. And here also the chlorine also need 1 electron to become stable. So they will share the electrons. They will share the electron. Okay. They will share the electron. Okay. So they will share this electron. Now hydrogen becomes stable. Okay, and let us see chlorine. So chlorine, the 6 plus 1 means 7 plus 1, it becomes stable. How many electrons it has shared? Only 1 electron it has shared. So it is single covalent bond. Single covalent bond. Okay. So let us see one more example. Hydrogen sulfide. You should know the formula. If at all they ask, write the dot formula for hydrogen sulfide. Hydrogen sulfide. Both are non-metal, hydrogen and sulfur. So what is the formula for hydrogen sulfide? H2S. You know how to get the formula. Just to recall. Okay. Hydrogen valency is 1. What is the valency for sulfur? What is the atomic number of sulfur? 16. So what is the outermost valence electron? That is 6, right? How many it needs? It needs 2. So the valency is 2. So when you cross and multiply, you get H2S, right? So that's the formula for hydrogen sulfide. Okay. Now let us represent. So hydrogen How many hydrogen are there? 2 hydrogen are there. And 1 sulfur is there. So how do you represent? Now all like this 2 hydrogen are there, 2 hydrogen atoms are there, and 1 sulfur is there. Now you should put it in such a way that all the 3 should get stable configuration, that is octet or duplet configuration. Hydrogen will get duplet configuration and sulfur should get octet configuration. So how do you write this? So here you should think before writing. So this is how we have to arrange the atom. Okay, so 1 electron of hydrogen and this electron of this hydrogen. Now how many electrons are there in sulfur? You know the valence electron is 6. Valence electron is 6 because sulfur atomic number is 16. When you put the electronic configuration 2h6, right? Outermost is 6. So we have to represent it. So how do you represent it? 4 over, right? Okay, and we write 5 and we write here 6. 1, 2, 3, 4, 5, 6. Now hydrogen got its duplet configuration, thus becomes stable, and sulfur got 8 electrons, right? So only 1 electron they have shared. Okay, so it is H. Okay, right? Only 1 electron they have shared. Okay, so this is heteroatomic molecule hydrogen sulfide. Okay. Now let us see how methane is formed. Methane is CH4. So now what is the valence electron of carbon? 4. Valence electron of carbon is 4. And 4 hydrogen are there. 4 hydrogen are there. So how do you represent? So we'll put here the 4 electrons of carbon, and here this is how they combine also, right? So 1 electron of hydrogen, each hydrogen, right? Now you see each hydrogen gets stable by getting duplet configuration, and carbon gets 8 electron. Okay, right? So how do you represent this one? We represent like this. Okay, so shall we do one more for water? For water, H2O. Oxygen, you know what is the valence electron? That is 6. So it needs 2 electrons. So how many hydrogen atoms are there? 2. So how do you represent? We put oxygen in the middle and hydrogen at both the sides. And we know hydrogen, it has only 1 electron. Okay, 1 electron it has, and oxygen has 6. So 4, 5, 6. Right? Now you see hydrogen has become stable here. Okay, and oxygen also becomes stable. How many electrons is sharing? Only 1 electron. Right? This is for hydrogen. Now you people do for carbon dioxide. Okay, so try for carbon dioxide. I hope now you understood what is covalent bond, okay, and how it is formed, and you have learned the different examples, okay, right? I hope you understood so much.